Hey guys, welcome back to Genius Learning. So this is the last part of this problem. In the beginning, we saw that this object goes up, it feels some air resistance going downward, okay? And then you'll always feel some mg in the down direction, always. Okay, so the ball goes up, or the object goes up, it reaches a max height at 0, so velocity 0 up here, and then that was for this part here, and we found that the position at this velocity final 0 can be represented as this. Okay, so now we're up here, and we're gonna start at 0 since we ended at 0, and we're coming down. So when we're coming down, mass times gravity, that's always in the downward direction. But now, since we're coming this way, the air resistance is upward. It's always opposing motion. And so upward motion is positive. And so we put that in our equation here. And we found that this here was our final position, okay, our height. And so we see that we can use this XH and this XH, okay, and set them equal to each other. All right, so that's what we're gonna do. So let's write this one first. So we're gonna do XH is equal to XH, okay, from both parts, the parts that goes up and the part that comes down, all right, because the XH here was where we started at initially, and the XH here was where we ended up finally. So they're both the same thing. Here it's the final height, here's the initial height, and they're both the same. So then we set them equal to each other. So we have this one here, which is 1 over 2k ln of negative g over k v final squared minus g, close parentheses, and then let's write this one over here. So equals, right, now we're doing this position height. So we have 1 over 2k ln, okay, we have k v initial squared plus g over g. All right, so now let's find v final, because that was initially what we wanted to find right before it hits the ground. Okay, so we can see that this 2k cancels with this 2k, and we have ln's on both sides, so we're just going to raise them both to the e. So if we just raise both sides to the e, the ln and the e's cancel. All right, and then we're left with negative g over k v final squared minus g. All right, and that's going to be equal to this inside here, which is k v final squared plus g over g. All right, so let's multiply this g and this g, okay? So we're gonna have negative g squared, and then we're gonna pass this to this side, where we're gonna have kv initial squared plus g, which is this, and then we're gonna pass all this over, and we're gonna have kv final squared minus g. Okay, so let's FOIL this out. We have here, this term is going to be k squared v initial squared velocity final squared. This term and this term minus g k v initial. Here we got plus g k v final squared, and the last term we got minus g squared. Okay, and on this side we have minus g squared. So if we pass this g squared to this side, okay, we're gonna have a positive. So this is gonna be g squared here, positive, and these two are gonna cancel out. All right, so we pass this to this side, and it canceled out here. And let's see what else we can do to try to get v final alone on one side. So let's take this to the other side, where we're gonna have a positive g k v initial squared from this, and we're gonna leave everything, this term and this term on the right side. So we're gonna have k squared v initial squared v final squared from here, and from this term we have plus g k v final squared. Okay, so we're almost there. So now let's take out v final from both of these terms. So we're gonna have v final squared. We're gonna be left here with k squared v initial squared, right? These two things. Plus we're gonna be left with these two things, gk. So everything here still equals the same thing. And let's go ahead and cancel some things. Okay, so well, let's go ahead and divide this entire thing to this side. All right, so we don't need to start doing that. So let's divide this to the other side, where we're gonna have this, which is gk v initial squared, okay, divided by, and from here, right, I'll do it in the next step. So we're gonna do k squared v initial squared plus gk. Okay, we pass this entire thing onto this side, and we have v final squared. Okay, so I'm gonna take out a k from this term and a k from this term out here, and it's gonna cancel with this k here. So this k, and one of these k's. So I take it out from here and from here, so it sits out here, and now I can cancel with the top part. And then I want to square root this side to get vf by itself. And so finally we have v final is going to equal square root of g v initial squared over k v initial, sorry, that should be a v initial squared plus g on the bottom. Okay, and so that's our answer. We could also take this v initial squared out of the root, but since I'm running out of space, maybe I'll write it on this side. So v final can also be written as v initial square root of g k v initial squared plus g. Okay, so both of these are the same thing. All right, so that's how we calculate the velocity final when we have drag, okay, going up and coming back down. Drag coefficient, we feel the air resistance, so we want to take care of one side and then take care of the other side in terms of their height, okay, and how we derive them. And then we set both heights equal to each other, and we solve for velocity here. Okay, so that's how you do this problem.